Hello guys! In this lecture, we will learn how to evaluate regression models. But first, let's import the libraries we are going to use in this section. Now let's import the Boston dataset, which is a dataset of house prices in Boston City. Basically, every house has some features, like number of rooms and number of bathrooms, and the house have a price corresponding to these features. For example, the house that have more rooms will usually be more expensive. Now we will split our dataset to train and test and fit a linear regression on our data. The first way to evaluate our regression model is mean absolute error. Mean absolute error is the simplest regression error metric. We will calculate the residual of every data point, taking only the absolute value of each, so that the negative and positive residuals do not cancel out. We then take the average of all these residuals. Effectively, mean absolute error describes the typical magnitude of the residuals. This picture is a graphical description of mean absolute error. The line presents our model predictions, and the points represent our data. The mean absolute error is also the most intuitive of the metrics, since we are just looking at the absolute difference between the data and the model predictions. Because we use the absolute value of residual, the mean absolute error does not indicate underperformance or overperformance of the model. Each residual contributes relatively to the total amount of error, meaning that larger error will contribute linearly to the overall error. A small mean absolute error suggests that the model is great at prediction, while a large mean absolute error suggests that your model may have trouble in certain areas. To use mean absolute error, we will import it from sklearn matrix and simply use it by passing our test targets and the predicted values by our linear regression model. The mean absolute error of our model is 3.16, which is not too bad, but of course can be improved. While the mean absolute error is easily interpretable using the absolute values of residual, often, depending on how you want your model to treat outliers or extreme values, you may want to bring more attention to these outliers or downplay them. The issue of outliers can play a major role in which error metric you use. To resolve this problem, we will use different metric, which is mean square error. Mean square error is just like mean absolute error, but squares the difference before summing them, instead of using absolute value. Because we are squaring the difference, the mean square error will almost always be bigger than mean absolute error. For this reason, we can't directly compare the mean absolute error to mean square error. The effect of square term in mean square error equation is most apparent with the presence of outliers in our data, while each residual in mean absolute error contributes relatively to the total error. The error grows quadratically in mean squared error. This ultimately means that outliers in our data will contribute to much higher total error in mean squared error. To use mean square error, we will import it from sklearn matrix and use it by passing our test target and the predicted values by our linear regression model, like we did with mean absolute error. The mean square error of our model is 1 to 1.5. If you want to downplay the outlier significance, you should use mean absolute error, since the outliers won't contribute as much to the total error as mean square error. The last type of regression evaluation model is Rsquared Score. Let's take a naive approach by taking an average of all the points by thinking of a horizontal line through them. Then we can calculate the mean square error for this simple model. Rsquared Score answers the question that if this simple model has a larger error than the linear regression model. However, in terms of metrics, the answer we need is how much larger. The best possible score is 1, and it can be negative because the model can be worse. In general, The larger the R-squared value, the more precisely the predictor variables are able to predict the value of the response variable. We will apply R-squared score the same way we did with mean square error. We see that the R-squared score of our model is 0.7, which is a very good score. So that's it for today's video, and see you in the next one.